As space probes journey past our planet, equipped with advanced sensors and instruments, they serve as our eyes and ears in the vastness of space, transmitting valuable data back to Earth. To interpret the information they send and adjust their course as needed, a robust communication system is essential, and that's where the Deep Space Network, DSN, comes into play. Imagine Voyager 1 on its way to the outer edges of the solar system, sending a faint signal back to Earth, traveling at the speed of light through the endless expanse. As the signal weakens over distance, the DSN's massive radio antennas are still able to capture that faint transmission, lock onto it, and transform it into data that scientists can analyze. But the DSN doesn't just receive signals. It also sends commands. The Voyager missions are dynamic, requiring adjustments to the spacecraft's direction, the activation or modification of instruments, and other crucial operations. These commands are transmitted through the DSN, ensuring the spacecraft stays on course, allowing scientists and engineers to guide it from billions of miles away. The DSN operates as a two-way communication system, connecting Earth with the farthest human-made objects in the universe. One of the remarkable features of the DSN is its continuous operation. It works tirelessly day and night, listening for distant signals, much like an unblinking eye on the universe, ensuring that we stay connected to our space probes, even when they are billions of miles from home. The Voyager mission, in particular, is a testament to the power of collaboration and innovation. While the spacecraft embarked on its monumental journey, the DSN ensured that it was never truly alone, bridging the gap between our planet and the uncharted reaches of space, enabling us to explore the outer planets and venture into interstellar space. However, despite the extraordinary success of the Voyager 1 mission, recent irregularities in its performance have sparked curiosity. The spacecraft is currently transmitting unusual messages back to Earth, suggesting uncertainty about its exact location. What makes this discovery even more puzzling is that the initial data received from Voyager 1 was completely unexpected, leading NASA researchers to a state of confusion. Upon investigation, scientists determined that the issue was caused by the Attitude Control and Gyroscopic System, AOCS, a vital onboard component responsible for maintaining and reporting the spacecraft's orientation in space. This system, which includes an antenna directed toward Earth to send data, unexpectedly switched to a malfunctioning backup computer that had been dormant for years. NASA engineers were able to correct the anomaly by instructing Voyager 1 to resume transmitting data via the correct computer, allowing the spacecraft to send uncorrupted information once again. Nevertheless, the exact reason why the spacecraft switched to the faulty computer remains unclear. While NASA has proposed the possibility of a broken command from another onboard system triggering the strange behavior, they have yet to identify the precise cause. To resolve this mystery, the team plans a thorough memory readout of the spacecraft systems and will conduct an in-depth investigation into its operations. It's important to note that despite the irregular data transmission, Voyager 1 itself appears to be functioning properly, with no malfunctioning health systems and a strong signal being sent back to Earth. One potential factor contributing to these anomalies is the harsh environment of space. Cosmic radiation, made up of high-energy particles from distant stars and galaxies, can interfere with the spacecraft systems, causing electrical disturbances, signal distortions, memory errors, and data corruption. Additionally, the extreme temperatures of space can fluctuate drastically, placing immense stress on the spacecraft's components. Despite the rigorous testing and careful engineering that went into designing Voyager 1 to withstand these conditions, the unforgiving realities of space can still cause significant wear over time. Another intriguing possibility that has captured the imagination of some is the idea of extraterrestrial interference. Could the strange behavior of Voyager 1 be the result of intelligent beings beyond our solar system? While this notion may seem more like science fiction than reality, it isn't entirely out of the question. The vastness of space and the countless exoplanets it contains leave room for speculation about civilizations far more advanced than our own. However, before jumping to conclusions about extraterrestrial involvement, researchers are thoroughly examining every aspect of Voyager 1's unusual behavior. Whether the anomalies are due to technical issues, cosmic radiation, or something entirely different remains to be seen. One thing is certain: the mysteries of space continue to captivate and inspire, fueling our relentless quest for knowledge and understanding of the universe. Explorer 1, NASA's farthest-traveling rocket, continues its incredible mission by transmitting remarkable data from the farthest reaches of the universe for nearly 50 years. This extraordinary spacecraft has revolutionized our understanding of space, but recently, its transmissions have been sending unsettling information back to Earth, leaving the entire space industry in shock. Are these troubling signals the result of a technical failure, or could they be signs of extraterrestrial activity? Join us as we uncover the truth behind these mysterious transmissions. Since the dawn of humanity, scientists have been fascinated by the mysteries beyond our planet. This curiosity led to the historic launches of Pioneer 1 and Pioneer 2, marking the beginning of numerous significant space missions. These groundbreaking missions, which have been studied for decades, began with the launch of Pioneer 2 from NASA's Kennedy Space Center on August 21, 1977. Just 2 weeks later, on September 5 of the same year, Pioneer 1 followed suit. These twin probes, each weighing about 720 kilograms, were launched into space as part of a grand tour of the outer planets. Their incredible journey took them in different directions and at different speeds, ultimately leading to a pivotal moment on December 15, 1977, when Pioneer 1 surpassed its twin counterpart due to differences in their paths. Since that time, Pioneer 1 has become an invaluable asset, providing us with a wealth of information and uncovering space-related secrets. Before we delve into Pioneer 1's latest shocking discovery that has stunned the space industry, let's look at the remarkable images captured by the spacecraft during its famous Jovian Imaging Challenge in 1978. At that time, Pioneer 1 was located around 265 million kilometers from Earth, and it sent back an extraordinary amount of images. In January 1979, it embarked on an extraordinary 100-hour mission, capturing a captivating time-lapse film that showed 10 rotations of Jupiter, providing us with a treasure trove of 3,750 images that allowed us to study Jupiter's majestic motion in intricate detail. In the following months, Pioneer 1 explored Jupiter's moon system, making a groundbreaking discovery: the presence of a faint ring around Jupiter and the identification of new moons. This further expanded our understanding of Jupiter's fascinating domain. To ensure safe passage and avoid a potential collision with Titan, one of Saturn's moons, corrective maneuvers were made. Pioneer 1 then continued its journey through Saturn's system, revealing 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. At the conclusion of the Saturn mission, scientists decided to end the planetary phase of the mission, sending both Pioneer 1 and Pioneer 2 beyond the boundaries of our solar system and into deep space, traveling at an astonishing speed of 325 million kilometers per year. In January 1990, a new chapter began with the Pioneer interstellar mission. During this phase, Pioneer 1 sent back some of the most iconic images in history, including a famous family portrait of the Sun and most of the planets. One key figure in extending the mission's scope beyond its original goals was renowned space scientist Dr. Vasily Sands. As part of the imaging team, Dr. Sands pushed tirelessly for one final set of images, which, against all odds, were successfully captured on February 14, 1990, when Pioneer 1 was 6 billion kilometers from the Sun. This farewell gift to humanity included 60 breathtaking images, including a planetary family portrait taken during its encounter with Neptune. Pioneer 2 also achieved remarkable feats. In 1986, it became the first spacecraft to fly by Uranus, and 3 years later, it completed the only flyby of Neptune. To this day, it remains the only spacecraft to have undertaken such a path. As the Pioneer probes continued their journey, NASA took steps to extend their operational life. Measures like deactivating non-essential components and heaters were implemented to conserve energy, ensuring that the Pioneer probes could continue their mission well into the next decade. The expected end date of their mission is set for 2030. For the scientists and engineers who have worked on these groundbreaking missions from the beginning, the results of the Pioneer missions are a mix of pride and melancholy. Their dedication and hard work have far exceeded initial expectations. The wealth of data returned by the Pioneer probes has led to significant scientific breakthroughs, sparked numerous discoveries, and inspired generations of researchers and space enthusiasts. Pioneer 1 and Pioneer 2 were not just ordinary space probes. They were meticulously engineered with a rotation rate more than 15 times slower than the hour hand of a clock. This design decision minimized visible blurring as the spacecraft captured images and data while traveling through the vast emptiness of space. Even before their encounters with the outer planets, these probes began to reveal the wonders of the universe. The astounding imaging capabilities of space missions have continued to surprise both researchers and the public alike. As rockets began transmitting images of Jupiter before even reaching the gas giant, the early photographs showcasing its swirling clouds and the iconic Great Red Spot delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanic eruptions on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals coming from Io, which were confirmed by the clear images of volcanic plumes and a surface marked by volcanic eruptions. One of Io's volcanoes erupted with a force more than 1,000 times greater than Mount St. Helens, covering an area nearly the size of France. Though the spacecraft's cameras were eventually turned off to conserve power and memory before venturing into interstellar space, it's important to note that the images they captured did not include Mercury and Mars for various reasons. In addition to the Voyager 1 and Voyager 2 interstellar probes, NASA has also launched other remarkable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Voyager 1, becoming the most distant spacecraft. Voyager 1 continued its solitary journey for another 14 years before finally entering interstellar space on August 25, 2012. However, NASA did not officially announce this monumental achievement until 2013. What ensured the success of the Voyager missions? One particularly notable technique was gravity assist maneuvers. These maneuvers played a critical role in propelling Voyager 1 and Voyager 2 on their bold missions to explore the outer reaches of our solar system. To reach these distant targets and gather valuable data, the spacecraft needed more than their own propulsion systems. They required a boost. Gravity assists provided just that. Imagine Voyager 1 approaching Jupiter, a massive gas giant with a powerful gravitational pull. With precision, Voyager 1 passed Jupiter at the correct angle and speed, allowing the planet's gravity to slingshot the spacecraft, boosting its speed and providing a significant lift. Performing a gravity assist maneuver requires incredible precision. Had Voyager 1 approached Jupiter at the wrong angle or speed, the slingshot effect could have caused it to deviate off course. However, the brilliant minds behind these missions executed these gravity assists flawlessly, propelling the spacecraft on an extraordinary journey through the solar system. For example, Voyager 2 used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial slingshots were essential in making the Grand Tour possible. The success of the Voyager missions can be attributed in large part to these gravity assist maneuvers. Voyager 1 continued its journey to interstellar space, and Voyager 2 followed suit, all thanks to the precision of these gravity slingshots. The concept behind gravity assists is simple, but their execution is extraordinarily complex. Voyager 2's Grand Tour required a level of accuracy so high that missing any of these slingshots could have resulted in mission failure. Nonetheless, the dedicated people behind these missions remained resolute and unwavering in their pursuit of knowledge. While gravity assist played a key role in exploring the universe, another important factor ensured the success of the Voyager missions. The Deep Space Network, DSN, often regarded as the interstellar telephone line that kept us connected to the brave Voyager probes as they ventured into the great unknown. Though less visible than the spacecraft, the DSN is just as crucial. The Deep Space Network is a system of large radio antennas strategically positioned around the world, including locations in California, Spain, and Australia. These massive dishes, ranging from 26 to 70 meters in diameter, act as enormous amplifiers, enabling communication with distant spacecraft.